This comes from your Unit 5, Lesson 1, Day 2 homework. This is question number 22. This is a review problem found on page 345 in your Course 3 textbook of the Core Plus Mathematics. Now, the reason we're reviewing this is we're going to need to solve quadratic equations and inequalities for the rest of this unit and a little bit of the next lesson. So we want to be able to do this. So we're reviewing a concept that you should have learned in 10th grade, perhaps 9th or 8th, but we're going to review it now so we can use it again very soon. So we'll start this expression. It says to solve each quadratic equation or inequality without the use of technology. So it begins by saying x squared minus 4x plus 4 equals 0. Well, I do remember this thing called the quadratic formula, so I'll write that out, negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And you might have remembered that, you know what, you can really write this all over 2a without two separate fractions, but I like to write it as two separate fractions. This can be useful as long as our expression looks like ax squared plus bx plus c equals 0. Hey, I've got that set up, but I tend to only use this expression if I can't factor it. So what I'm going to try to do first is try to factor this if I can. Now, factoring means I want to find things that are going to multiply this to the 4, but that will add to a negative 4x. Now, we've done this in lots of different ways, but one of my favorite ways to do this is actually to use a little Punnett square, a little factoring box. All right, and so what happens in this Punnett square is we put in the constant in the bottom right-hand corner, you put in the x squared in the top left-hand corner, and then what you do is you have to think outside of this. Combinations of x and x would multiply to x squared. So I put an x and an x here. To get to a positive 4, I have lots of combinations. I can multiply 2 by 2 to get to 4, but a positive 2 and a positive 2 would not add to a negative 4. However, if I think of this as a subtract 2 and subtract 2, or minus 2 and minus 2, a negative 2 times a negative 2 does multiply to a positive 4, but this part, x times a negative 2 becomes a negative 2x. X times a negative 2 is also a negative 2x. Those combine then to be negative 2x plus negative 2x, negative 4x. That would work. So the factors then are what's on the top and what's along the side. And those are your linear factors that when you expand them should go back into giving you x squared minus 4x plus 4 equals 0. Once you have linear factors, that means that these factors, when multiplied together, have to equal 0. Well, that means that either x minus 2 on the left equals 0 or x minus 2 on the right equals 0. Well, it turns out that if you let x be equal to 2, opposite this factor, then you would get 2 minus 2 is 0, and this would multiply 2 minus 2 to get 0, and that's the solution. And it happens to be the only solution to this quadratic. So it must be that on the graph of this function that this is crossing with only one x-intercept at 2. All right, so there's my solution for the first part. Now, I could have used the quadratic formula and I would have gotten the same answer. This back part, b squared minus 4ac, would have gone to 0, so I would have just had this piece in the front that read 2. Let's go to b. B now says x squared plus 6x plus 8 is less than 0. Ooh, it's an inequality, which means I'm dealing with a range of values that will make the statement true. Now, this parabola, if I look at the front of it, there's no negative sign in front of the x squared. So this is a parabola I know that opens upwards. I know it has a y-intercept of 8, but I'm not really sure where it crosses the x-axis. Where it crosses the x-axis is where it's going to equal 0. So if I think of that for a minute, where does it equal 0? Then I'm going to go ahead and try factoring this again, just like I did in the first part. I'm going to let x squared go here, 8 go there, and I need combinations of multiples of 8, factors of 8, that will add to be 6. Well, I know that 2 times 4 multiplies to 8, and 2 plus 4 adds to 6. So I'm going to write this one as x plus 2, and this one as x plus 4. And now I'll know this is 2x and 4x, and I know I'll get my expression out. So my factors are x plus 2 and x plus 4. And if I set that equal to 0, that means that I will get a 0 out when x is equal to a negative 2. Negative 2 plus 2 is 0. Negative 2 plus 4 would be positive 2, but it doesn't matter. I'm multiplying by this. 0 gives me 0. Or I know that x plus 4 has to be equal to 0. If I put a negative 4 in for x, negative 4 plus 4 goes to 0. And even though negative 4 plus 2 is a negative 2 over here, multiplying by 0 turns this to 0. So my two solutions are x equals negative 2 or x equals a negative 4 to where this is 0. However, this expression is an inequality we're solving. We want to know for what values we are less than 0. So here it helps to maybe do a quick sketch. So my quick sketch yields that negative 2 would be a 0, and negative 4 would be a 0. We're going to intercept the y-axis at 8, and we have a parabola opening upwards. Okay, so on a quick sketch, something might look like this. I don't know what the minimum value necessarily is. I could find it, not asked to. I'm just asked to interpret for what x values does the parabola fall below 0. Well, that would be for all of this space down here. All of this is below 0. Well, that happens for values between this x value and this x value. So I want to say x values between a -4 and a -2. So I'll say -4 is less than or equal to, wait a minute, not equal to, just strictly less than, because that's what symbol we're using, the less than symbol. So -4 is less than x, is less than a -2 is the correct answer for this. And I could write that using interval notation if I'd like as well, -4, comma, -2, parenthesis, because the two endpoints are not included, because it's not an equal sign underneath. So that solves B. Let's go to part C. C reads x squared minus 4x minus 5 is greater than or equal to 0. Again, this is a parabola that opens upward. There's no negative sign on the x squared. I want to try factoring this if I can, because I'd like to know where it equals 0, so I can then reference the 0 to figure out what values will yield the appropriate x values. So this is x squared. This is a subtractor, -5. I need combinations that multiply to -5 that will add to a -4. Well, I'm going to stick to x and x here, but then do -5 and a +1. This turns to -5x. This part will turn to a +1x. -5 and a +1 add to -4. So my factors are x minus 5 and x plus 1. And if I want to know where those equal 0, the zeros are opposite these factors. So one of my zeros will be at 5. The other 0 will be at -1. I'm going to do a quick sketch here for a reference. 0 at 5, 1, 2, 3, 4, 5, and a 0 at -1 goes here. This intercepts at -5. So I know this curve does something like that. So I want to know where the curve is greater than or equal to 0. Here's the 0 marker. So I'm greater than for this piece up here and this piece up here. So I need x values that go left, and I need x values that go right. So I need x values that are left or less than or equal to a -1, or I need values that are x is greater than or equal to +5. I need both of those. If I want to do this in interval notation, I could go -infinity, that's with a parenthesis, comma, -1 bracket, unioned with the bracket at 5 and parenthesis with the positive infinity. And that is my interval notation. That solves C. On to part D. X squared plus 14x plus 42 equals a -7. Now, first thing to note here, this is not equal to 0. So I can't use the quadratic formula without equaling 0. So I'm going to start by adding 7 to both sides of this. I can now get x squared plus 14x plus 49 equals 0. And then I have a sense that, hey, wait a minute, I know 49 is a perfect square. 7 times 7 is 49. I also know that 7 plus 7 is 14. So I know this is going to factor out really nicely for me now. This is 49. This is x squared. This is 7x and 7x. Therefore, x plus 7 times x plus 7 is going to equal 0. Therefore, x will have to equal a -7 to make both of these equal to 0. And that's my solution number 22.